All right. Hey, everyone. We're going to get started. I'm sure some more people will trickle in. The good news is the room currently is set up to be a very COVID-friendly room because everyone can have their own row. My name is Sean Falconer, and this is enabling data privacy, payments, and analytics with an API. So the game plan for today actually is that most of the session is hands-on. So you're going to actually be building a lot of this stuff. And if you've never programmed before, don't worry about it. You can team up. Maybe this is your opportunity to learn a little bit. Our CRO, Tammy's in the back of the room hiding, and I know that she really wants to learn how to program. So this is her opportunity. Yes. So the price of admission, though, to get to the fun stuff, to build things, is that you have to listen to me for 20 minutes. Talk about some of this stuff, but most of this is going to be setting context for what you're going to be building, why we want to try to build things like this to preserve privacy, to do cool things like money movement and analytics and so forth, the types of things that you would do in any modern application. Before we get there, though, a little bit about myself. So I'm head of developer relations at Skyflow. And fun fact, one of my sort of hobbies is that, and this probably varies depending on your definition of fun, but I really like taking things like machine learning, statistics, data science, concepts from computer science, and mashing those things up with things from popular culture. So if you've been by our booth, you might have experienced a little Star Wars themed demo that teaches you about data privacy while you use essentially a data privacy vault to keep the rebel forces protected from the Empire. That's the kind of stuff I like to do. So one of the most popular things I've ever done is using machine learning model to actually predict the winner of the television show Survivor. And my articles on Survivor have actually received over 100,000 views. And my articles on sort of the gender and actual racial biases that exist in the show historically are required reading at Queen's University in sociology and psychology classes. So if that's your idea of fun, you're in for a treat for today. And then last thing before we start to jump into this is I snuck in here earlier, and underneath 2 chairs in this room is a piece of paper. So you'll have to dig around because there's not that many people, but if you can find those pieces of paper, I think there's maybe somewhere in the middle of this vicinity and maybe over here somewhere. There you go, he's found one. There's one more around, perhaps in this row that only has one person in it, and this woman in the blue shirt is in the back of. There could be maybe one sneakily over there. Anyway, the person who found the piece of paper, what's it say? Yes, so you are a winner, and one other person will be a winner if they find it. We're all winners, but I think he found one. All right, so you are just an extra special winner, so I have something for both of you here. All right, so I have some vintage Skyflow socks, which you can no longer get, and a charger, as well as a privacy proof for your laptop. And you found the other one? There you go. Thank you. All right, now that the bribery's done, let's get into this. So when we talk about data privacy, it's impossible to talk about data privacy without talking about data, essentially. Like data is the new oil. You may have heard this phrase or concept. And basically, businesses are collecting and processing more data all the time. And we use that data to inform decisions about our products, deliver ROI for our businesses, and so on. But when we talk about data privacy, the really important thing that we need to understand is that not all data is created equal. And when we're talking about, in particular, sensitive customer data, things like people's names, social security number, financial information, healthcare information, that type of data just requires better protection than others. It doesn't belong essentially intermingled with our regular application data. And we're collecting all this data for companies today that we use to do all these amazing things like machine learning, generate reports, data engineering, new fields and new types of companies like Snowflake and Databricks. But the really important thing that we all need to understand is that this sort of small amount of data that can be used to identify an individual, if it falls in the wrong hands, it can be used to harm that individual, or it's highly regulated and it can be used essentially to fine a company if you don't follow the rules and regulations of using that data and protecting that data. This data is special, and that's a fundamental thing that we need to understand. Just like when it comes to special physical documents like my daughter and my son's birth certificates, or my passport, my green card. I don't keep those physical documents in the junk drawer in my kitchen with my batteries and my flashlights, because those represent fundamentally different things. If my batteries fall into the wrong hands, it's maybe mildly irritating, but I can replace that. If my daughter's birth certificate falls into the wrong hands, that's a big deal. I don't want it destroyed. It's a huge hassle to replace, and I wouldn't want that to be like an identity theft issue. So that same care and thoughtfulness we apply to these important physical documents in real life, we need to apply that to customer data. But what ends up happening with customer data in most applications is essentially we take that data and we stuff it into some sort of data store, a users table historically, and then we end up sort of copying and replicating that everywhere. So we take a simple example of something like someone's phone number. We collect that phone number in the front end and probably other types of elements about somebody, and we end up sending that phone number down through these downstream services like an API gateway, a load balancer. It ends up in a log file. And then it goes to a back-end system. It ends up in a log file. It goes down, we store it in our database, and maybe that kicks off some ETL process. And then that ETL process saves that phone number again inside our data warehouse, and then we're running machine learning and reports and analytics off of data in the data warehouse. So why is this a problem? Well, this is a problem because essentially this PII, the phone number in this case, as well as other elements about the person, ends up copied, fragmented, and replicated throughout these different systems. And this is a problem because basically companies, they can't answer basic questions about what data are they storing and where is it stored. Imagine if you took your social security card and you made 1,000 copies of it, and then you distributed those 1,000 copies all over the place, and you tried to protect all 1,000 locations. That's a much harder problem to solve than having one card that you put in a safe or a safe place in your home. But that's what we're doing when we build applications. We're taking these data and we're basically creating a proliferation of it, and then we try to protect all those locations. So that makes compliance really hard, and it makes it really hard for a company to be able to know, are they actually securing customer data? And if you do that on every node and edge of the graph, I mean, this is a pretty simple system, but modern systems are much more complicated. 20% of enterprise businesses store data from over 1,000 sources into their data warehouse. That's a lot of nodes and edges. And the monolith is dead. These back-end systems are hundreds or maybe thousands of different microservices. That's a lot of points in a graph to try to protect. So how do you solve this problem? That's like really the fundamental question that all these different companies are trying to wrestle with. Now, if you look at some of the leading technology companies in the world, companies like Apple, Google, Netflix, the way they address this challenge is by pioneering a technology known as the Zero Trust PII Data Privacy Vault. And their key insight, which goes back to something that I was saying earlier, was that they recognized that their customer data, which is core to their business, is something special. And because it's special, it doesn't belong intermixed with all the regular application data. So they took that customer data and they moved it out of their existing infrastructure and existing data stores and moved it into these PII data privacy vaults. And what that does is it essentially creates a single source of truth that's isolated and protected within the secure environment. And it descopes their existing infrastructure from responsibilities of compliance and data security, just like we want to have a single copy of our social security card that we're putting in a protected location. But the disadvantage, of course, of locking your social security number or card away is you can't use it. But with modern technology, we can actually lock things away and still utilize it. So what exactly is a data privacy vault? Well, data privacy vault isolates, secures, stores, and tightly controls access to manage and use sensitive data. And this isn't a new concept. If you walked into an office building from 50 years ago, you're not going to typically find employee records, financial records, and customer records in files intermixed with like today's lunch order. Those things are going to be probably at least in a locked cabinet or in a safe, and only a few people within the business have access to it. And that's essentially it's analog, non-digital isolation of data and data governance. And we can do a lot better now using modern encryption and other techniques to protect the data than a key. So when you start to break this down, in terms of isolation, this needs to live on a segregated network, needs privileged access. Every access needs to be logged and audited, and you can use those logs and auditing to actually use machine learning on that to predict data breaches. You need to secure the data using privacy-enhancing technologies like data masking, encryption, tokenization. This is core infrastructure. This is your customer data, so you need high throughput, high availability, support for structured and unstructured data, enterprise-grade performance, essentially. And you need to be able to manage or govern access around the principles of zero trust. So zero trust, essentially no one and no service has access until explicitly give it access. And the access should be based on the actual business requirements of that services accessing it, and on how they need to actually see that data, walking down the rows and the columns and so on. If you think about, if you're an engineer, you built a system, you think about how many lines of code in some system you worked on actually need access to someone's email address. Yet, typically, we give the entire system access via API or to the database to that email address. And that just essentially it opens up the number of attack surfaces that could happen. And then we store all this data for a purpose, so we can use it. It's one thing to put something in a protected storage and then throw away the key, but that's not very useful. So we need things like privacy-preserving analytics, database-like access so we can integrate it into existing systems under a familiar paradigm, and secure cloud functions so we can perform operations on the data and maybe pass the data to third parties to do things like send a text message through Twilio or perform a money movement operation. And some of these things are what you're going to get to do during the hands-on portion of today's workshop. So if we go back to this example we were talking about earlier, where we essentially have this, the sort of fundamental problem here is we're just replicating this data everywhere, which makes protecting it an intractable problem over time. When we introduce the data privacy vault, what happens here is that ideally we are de-identifying data as early in this life cycle as possible. So if we're collecting something like a phone number and an application front end, we want to send that into the data privacy vault directly, building a schema that essentially represents the type of data that we want to collect. And then in exchange, we're going to send a token back. And the token essentially is a proxy to the original data, but there's no mathematical relationship between the token and the phone number. So someone can't reverse engineer it even if they get the token. The only way they can essentially retrieve the original number would be through detokenization, which is a very privileged operation to perform. So now we're going to still send all this data downstream through these different services, but instead of the original phone number, we're sending this token. And we can still perform all the analytics, operations, and things like that against tokenized data. And what we've done is we've effectively de-risked this entire area of the stack. And we've created now a single source of truth that's isolated and protected within the vault, and any other operations that we want to perform directly on the PII should be happening within the secure environment. All right, so that is a little bit of background about data privacy challenges companies face, and the essentially conceptually how a data privacy vault works. But the easiest way to really, I think, start to understand these things is to get your hands on it, on this stuff, and actually build something with the technology. So that's what we're going to start to do. And what you're going to be building is something called Instabread. So Instabread is like Instacart, but only delivers bread. So it's a bread marketplace. It's made up, but once you guys build this today, I'm going to sell it for millions. So thank you very much. The bread marketplace essentially has clients that want to get bread on demand, or bread enthusiasts, and then there's shoppers or gig workers that go out, get the bread, bring it back, deliver it, just like Instacart, but bread only. And what you're going to be building is the Instabread shopper sign-up experience, so the gig worker sign-up experience. And to do that, there's certain requirements. So it needs to be mobile first, because gig workers are on the go. It needs to be able to collect PII to create accounts for the workers and do that in a secure way. They need to be able to select bakeries or grocery stores that they're willing to travel to. They need to be able to put in banking information so that they can get paid. And then finally, we want to be able to store all this data downstream into databases and data warehouses in a way that preserves privacy but still allow us to perform all these kind of analytical operations. So don't worry, you're not going to be doing all of this stuff. So the stack is, the front end is React, and on the back end is Node. And for application storage, we're using AWS DynamoDB, and then for the data privacy vault, we're using Skyflow. And then for money movement, we're using this company you might have heard of, Moov.io. They sponsored this cool event called Fintech DevCon. So we're going to be using that to their APIs securely through the data privacy vault to actually perform money movement to pay our gig workers. And then for data cloud, we're using Snowflake. Now, the actual application storage in the data cloud for what you're going to be working on is taken out. You don't have to worry about it. You're going to be basically just doing the data privacy vault integration as well as the money movement piece. But for the demo, I'm going to show you how the whole thing works if you're to build everything. All right, so we're going to hop over to a demo. All right, so this is Instabread, and I'm going to go ahead and click sign up. So when you're using this, most of the front end's built for you. You're really just going to be doing the hooks into how you store data and process data. So I'll put in my information here. So I'm going to sign up as a gig worker. Oops. And hit create account. So what's happening here when I create the account is, just like we showed in the diagrams earlier, we're going to send that data not to a backend service. We're going to send it directly onto Skyflow to store it within the vault. So if we go over to Skyflow Studio here and refresh this, we can see now that there's a shopper record in here. And I see this data as masked or partially redacted and redacted based on the roles and the policies and the configuration of the schema that's built for the vault. All this stuff's going to be taken care of for you, but essentially through data governance that's supported within Skyflow, we want to be able to control how a user or a service sees the data, what data they have access to. And for something like email, for example, we can see the data is redacted using masking. There's encrypted operations to perform, actually fully encrypted operations so we can do things like lookups or computations against the data without decrypting it, and we can, of course, tokenize it. And what's happening downstream is we're also storing that data in DynamoDB, but instead of storing the raw PII and replicating it there, we're storing tokens. So these are the proxies, essentially, for the original values. And you can see, for example, with email, it's still formatted like an email, but it's essentially a tokenized form. So this is using something called format preserving deterministic token. So whenever I put in my email, it's always going to create the same token value. And then finally, the data ends up in Snowflake here, and we can take a look at what that looks like. If I query the table here, I see the record, and it's actually a JSON blob that's written into there. And we'll go over the details of kind of how this system works. But now that we have tokens essentially in our data warehouse, and we could be doing this from other sources as well, presumably if you're using something like Snowflake, you're probably collecting data from all over the place, and you're gonna, whether that's an ETL pipeline or it's an application collection process, you're gonna be de-identifying that data as early in the life cycle as possible and essentially generating these different deterministic tokens that then you can run analytics over. Because when we're talking about analytics over PII, it doesn't matter that Sean Falconer is stored as the name representation in the data warehouse or a UUID, because the analytics doesn't care. You're just doing bucketing over these types of things. All that matters is whether you're creating a consistent value for Sean Falconer. And the fact that we're storing a UUID instead of my name means that now if someone got access to our warehouse or we leaked information, it's just tokens. It's like meaningless. And I don't have time to go into this, but there is a way to actually, through an integration that we built with Snowflake, to de-tokenize these values directly within Snowflake with privileged access if you do need to retrieve the original values too. All right, so we're going to go through the rest of this app. So this show just goes over how Instabread works. We'll continue here. These are the requirements for shoppers, so over 18, able to lift 40 pounds, eligible to work in the United States, love bread. Who doesn't love bread? I meet the requirements. And then you select which places we're willing to travel to. And again, this data is going to be stored in the vault because presumably if a gig worker is selecting bakeries and grocery stores they're willing to travel to, it probably says something about the geolocation of that individual. So we want to store that. It's potentially sensitive. As a company, as the CEO of Instabread, I wouldn't want that getting leaked on the Hacker News. All right, so put in my banking information now. And when I save this, what's happening is this data is being saved within the vault, and then we're actually sending that data on securely to Moov. So if we go over to the Moov admin dashboard, I log in again, and I go to accounts, I can see this account just got created in here. So that's all happening securely through the vault, and I can see that Chase Bank was created here. All right, so I've signed up, congratulations. And through the magic of the demo experience, I've already performed some deliveries of bread and earned $64, so I can actually cash out and perform money movement. So again, this operation is going to go securely through the vault to Moov. So I'm constantly insulating essentially all my backend systems from touching any of this stuff. And if I go back to Moov and I look at transfers, I can now see that there's a pending transaction from Instabread to the account that I just created. All right, so that is Instabread. All right, so I guess one last thing, sorry, this is how this application works. Very similar to what we went over before, where essentially the application front end, any sensitive data is going to go directly into the vault using the Skyflow front end SDKs. Oh, there we go. Tokens get sent back. and then we're going to use those tokens to call the Moov APIs through Skyflow. So rather than passing the data directly to Moov, we're essentially using the token values to securely call something called Skyflow connections that then automatically de-tokenizes that data securely within the Skyflow environment and passes the values over to Moov to create the account. Then we're going to send tokens through the back end to DynamoDB. There's a Lambda function set up in AWS that gets triggered whenever a new record gets written into DynamoDB, and that kicks off an ETL process where that record gets written as a Kafka message to a Kafka broker, and then through the Kafka connector for Snowflake, it gets written down into Snowflake. The tokens end up in Snowflake, just as you saw, and essentially we're de-risking this whole back end. All right, so now it's your turn. So what we're going to do is you're going to go to github.com/default/instabread-codelab-sample. If you have any problems with that, let me know. And that's the repo you're going to basically clone. The whole front end is built. You're really just putting in the hooks using the instructions that are available within the README there. It's essentially set up as a code lab. And if you run into any problems at any point, raise your hand. I'll help you. There's some other people. Oh, sure.
Sorry, question. So when you send the tokenized data to Skyflow,
Mm-hmm.
how does Skyflow know how to detokenize it? Are you sharing some kind of secret with this?
Yeah, so any API call is essentially you're authenticating that API call using a service account key. The service account key has a role attached to it, and the role has a policy attached to it. And the policy dictates how, essentially that service account, what data it has access to and how it sees that data. So not every policy is going to allow detokenization. Depends on how, essentially you want to map that policy to the specific business requirements of the service that's accessing it. And that's some of the stuff that you'll do during the lab. And if you find any bugs, let me know. Maybe you'll win a prize. If you find a bug in Moov, I'll point you to Jared here. A couple other things. So and actually, if you accomplish something like storing data in the vault, let me know and I can celebrate with you. But I have sheets here, and this includes all the things that you need for the lab. So I've created Skyflow accounts for everybody. Chi, do you mind taking these? Oh, here, maybe you can pass some of these back. I've created Skyflow accounts for everybody, so you don't have to sign up for Skyflow. You can just use the account that I've already created, as well as there's a section in the lab that talks about signing up for Moov and using Moov's dashboard. You can skip that. The sheets have API keys for Moov. So in that section that talks about that, you can basically ignore the stuff about ngrok and signing up for Moov and just use those API keys. But you do have to export some environment variables. But when you get to there, if anything seems confusing, just essentially let me know. And essentially, this is over to you, and I'll circulate and help people as we need, and hopefully we don't run into too many configuration issues. The other thing is there's only 20 Skyflow accounts, so there's a chance that you're in the same account as somebody else. It's totally fine. Just create your own vault, be a good vault neighbor, and don't mess with someone else's vault. So I didn't expect everybody to finish or anything like that. There's a lot of stuff, so feel free to continue on your own if you want. Hopefully I know we ran into some internet issues, some configuration issues. That always happens when you do these kind of hands-on things, but hopefully you got a little bit of played around with this. I know a couple people got pretty far, so but I just want to say thank you so much for putting time into this. I know it can be hard to be thrown into the deep end to try with one of these things, so I appreciate the patience and trying it. Now, if you're interested in any of this kind of stuff, data privacy, data security, running into these issues at your regular job, your day job, feel free to join our community too, skyflow.com/community. It's a general data privacy community, so it's like bringing experts together, people working in the industry. You can ask questions, discuss there. And if you have any questions, feedback, anything that comes up, feel free to reach out to me too at my email, seanfalconer@skyflow.com, or you can reach me on Twitter too. But I'll be around the rest of the day if anybody wants to chat. And if anybody has questions right now, I think we probably have a few minutes for those too. All right.
Thank you.
Yeah, thanks so much.